Hey guys, I usually go over the practice exam before the exam, so I guess I'm going to do that. I should note, I said on the practice exam only do problems through problem 9. I guess I said. You should probably, the last problem is also a fair problem for this exam, problem 13. So it's just 10, 11, and 12 you should skip. If you didn't do problem 13, you can still do it. And it's just like a million homework problems we had, although simpler. Let's get started. We want to sketch a function f that has f prime less than 0 on x less than 3, f prime of 3 equals 0, f prime is bigger than, all this stuff. I guess I want to draw a sign chart. You don't need to for this problem, but it's easier for me to organize this information. The points that we care about on the x-axis are 3 and 5. So I need to mark those. 3 is significant because that's where the derivative equals 0. 5 is significant because that's where the second derivative equals 0. I should label these rows. And then what's happening? Left of 3, f prime is negative. To the right of 3, f prime is positive. To the left of 5, f double prime is positive. To the right of 5, f double prime is negative. So this chart has all the information now. What do these look like? This part is concave up, this part is concave down. If you are increasing, so here we are decreasing and concave up, that's this shape. Here we are increasing and concave up. The increasing half of the smiley is this shape. Here we are concave down, but increasing is this shape. So that's like that. So any graph that at 3 transitions from this to this, and then at 5 transitions from this to this, will do it. So I need to mark 3, I need to mark 5. I can put a y-axis if I want to, and anything that at 3 needs to go dupe. At 5 we need to be something higher, so make sure this is increasing concave up. Make sure this is increasing concave down. Make sure this is decreasing concave up. There's an answer. Hooray! Sometimes on exams I'll give more specific information. I could have said f of 3 equals whatever, f of 5 equals whatever, in which case now we need to put these points at specific places before we connect the dots using the correct shape connections. That's not really extra work though. Find these critical points and categorize them as local max, mins, or stationary points using any method. Let's take the derivative. Derivative of that function is negative 9x squared minus 7 times 4 is 28, x cubed plus derivative of 4 is 0. I want to know when does this equal 0. I can also think about when does this doesn't exist. This is never undefined. That's not an issue. Right. When does this equal 0? I guess I want to factor this. I can factor an x squared out. X squared negative 9 minus 28x equals 0. That equals 0 and one of the factors equals 0. That's x equals 0. Or negative 9 minus 28x equals 0. So that's negative 9 equals 28x. So that's x equals negative 9 over 28. These are the critical points. And I need to categorize them as maxes or mins or stationary points. Here's a place where the derivative is easy to take we could take another derivative and use the second derivative thing, but the second derivative is not going to be always negative, always positive. I think the easiest thing to do is just, let's make a sign chart for f prime, see when it's increasing, decreasing. 0 is to the right of negative 9 over 28. What is negative 9 over 28? It's very small. It's like negative 1/3 or something. These are the places where the derivative equals 0. I guess I'll take f prime of 1 is negative 9 times 1 minus 28 times 1. That's negative. Negative 9/28 is a fraction, so negative 1 is left of that. Let's take f prime of negative 1. Negative 9 times negative 1 squared is 1, minus 28 times negative 1 cubed is negative 1, So that's positive 28 and negative 9. That's going to end up positive. Right, and the hard one is what's happening in between 0 and negative 9/28. What's between 0 and negative 9/28? What is negative 9/28? I guess that's worth working out. A calculator. What is negative 9 over 28? It's negative 0.3, so negative 0.1 will work. So I need negative 9 times negative 0.1 squared minus 28 times negative 0.1 cubed. It's negative 9 times 0.01 minus 28 times negative 0.001. I'm getting negative 0.09 plus 0.0028. You're more negative than he is positive, so the answer is going to be negative. So I'm getting a sign chart like this. Our graph increases, then decreases, and then decreases after that critical point. So negative 9/28 is a local max, and 0 is neither a max or a min. That's a stationary point. Cool. Here's a function. Find all the local extrema and all the inflection points. Okay, let's take the derivative of this function. Is it worth foiling this out? Yeah, I guess it's probably easier to take the derivative if we FOIL it out. That's often for these things, like if this had a big exponent on it, I wouldn't want to FOIL that out. I'd be using the product rule. The fact that I don't have to lets me get around the product rule. That seems easier. I got 4x squared minus x cubed. What's the derivative of that? It is 8x minus 3x squared. I want to know when that equals 0, but while I'm in a derivative taking mood, let's do the second derivative. Second derivative is 8 minus 6x. I want to know when each of these equals 0. This one I want to factor. I can factor an x out. I left with 8 minus 3x. When do u equal 0? That's when x equals 0, or 8 minus 3x equals 0, that's 8 equals 3x, that's x equals 8/3, or 0. These are the critical points. They might be maxes or mins, but we don't know yet. 8 minus 6x equals 0, that gives me 8 equals 6x, that gives me x equals 8 over 6 is 4/3. That's our only subcritical point. That might be a point of inflection, but we don't actually know yet. Okay.